Okay, I'm starting the recording. I'd like to welcome Pete McLaughlin, who's teaching the same course at the University of Delaware, and we'll make the video available to them at the U of D. Oh, Pete left a meeting. Something must have happened. Anya, where is everybody?
I don't know. You know, like normal. Maybe they're in the Zoom meeting. Let me pop in there on my other computer and see.
Okay. The reason why I like using WebEx is at the risk of getting bombed. I can just have people like drop in who are, just come on in. And besides, if somebody wants to Zoom bomb me, I know a lot more curse words than they do. That's what time at the United States Naval Academy will do to you, folks. If I can't out cuss them, God bless them. Oh, I almost wish for it. It would be rich. So what's going to happen today is we have someone live from the Jersey Shore who's going to be on the beach at North Beach, Sandy Hook. And I will take you there virtually on this field trip to North Beach and start out with about 25, 30 minutes of traveling there. This is part of what we would call a Coastal Techniques and Processes field trip that we run to Sandy Hook, which is part of Gateway National Park. So Sandy Hook, this is a view. This is the Atlantic Ocean. This is Sandy Hook Bay. This is Raritan Bay up here. This is a sand spit. It's building out into the Atlantic Ocean. There's a lighthouse here, which was built, as we'll see in a minute. It is one of the oldest operating lighthouse in the United States, 1764. You can see there's been nearly a mile of progradation since this lighthouse was built in 1764, 2 years before Rutgers University was founded, this lighthouse was. So again, it's a peninsular spit, sand spit building into Raritan Bay this way and Sandy Hook Bay this way. This is a geological map of the region. So over here, you can see this green is Cretaceous, capped by, I believe this is Miocene. At least when I went there, it was Miocene. The yellow is Quaternary. See, this is all Quaternary. This is a geological map. North is essentially to the left. We'll look later at a cross-section through this, but we did a little investigations here back in 2014 to 2016, drilling sites at the North Maintenance Yard, the Salt Shed, and the South Maintenance Yard. So again, the Atlantic Highlands, which are here and here, are the highest point on the East Coast. That's right at the beach. I'm going to take you on a little tour. So to get to Sandy Hook, one way is coming from Rutgers. You're going to end up crossing this bridge. This is the Route 36 bridge. It's got several different names. We'll see one of them in a minute. As you come down, you wrap around and you head into the peninsula, which is officially Gateway National Park. And until the tragic events in Sandy Hook, Connecticut, certainly Sandy Hook was the most famous of various Sandy Hooks around the country. But as you wrap around and come into the park, you'll normally roll up in the summer to a toll plaza, which takes your $15, soon to increase to $20 to enter into the park. So to our left is the bay, and to our right will be the Atlantic Ocean. So the peninsula goes up about, John, what is it? How many miles is it? It's more than 6. Again, John's on the ground there. And you can see, how long is this spit again? Is it 6.5 miles?
approximately. The Sandy Hook itself is 10 kilometers, and if you go from, if you include Seabright as part of the barrier spit, it's 16 kilometers.
Okay. So we just entered Gateway National Park. Gateway National Park, of course, extends over into Long Island and is administered there. An interesting side point is that the park superintendent for this portion of the park is married to the park superintendent for the overall park. And so he was very gracious and helpful for some of our research here. So J.N. Stanley, one of our graduate students, is doing GPR lines. I didn't upload his data yet, but I will show you that at some point. And we're just coming up here past one of the first beaches. And we're going to continue up. I won't take you all 6 miles up, but I'm going to take you up as far as the first Nike site here. So normally we would be driving together in our vans from Rutgers about 35 minutes out. And people in my van, I'll be telling you all these boring stories that you're going to hear now anyway. So this is a way of torturing you to get some of the geological history. A lot of this was studied by Jim Menard of the United States Geological Survey and looking at the Quaternary Geology, and our own Norb Sudi. Norb was director of the Rutgers Coastal Institute until 1989 when it was supplanted by the Rutgers Marine and Coastal Institute. But Norb was responsible, and he still has an office out here at the end, which is part of the former port, but the National Oceanographic and Atmospheric Administration has offices out there. I don't know if you ever heard of the organization that monitors the beach. Clean Ocean Action has offices out there. And there's no longer a full military presence, but this was very important area in the defense of our country, as we will see in just a minute. Again, beautiful place for cycling. Okay, as you can see, the cyclists on the side. Beautiful place for walking along. There's miles of trails through this area. It is relatively pristine, except for the fact that if you dig into the beach, they're always warning you, you may find unexploded ordnance. Because again, this was a fort defending the United States beginning in 1896, I think. But also, it was very important during World War I and World War II in the defense against ships coming in, German ships. But it also became very important in the Cold War as one of the major Nike missile bases in this region. And as we proceed north, let's see how much more we have. Just a little bit more. I'm just going to speed it up a little bit here. So as you come up here, you'll see on the left a missile, which I'm sure many of you have not seen before. The missile that we will see is a Nike, I believe it's a Nike Zeus missile. There were 3 generations deployed, Nike Ajax, Nike Hercules, and I believe this is a Nike Zeus missile. And that's on the left and on the right. And on the right is the South Maintenance Yard, just for in geology and going into the field. It's important to get yourself oriented to where you are, both geographically. So this road is almost running north. Our field area today is about 4 miles further north, as we'll see in a minute. So the Nike base, where we just left off, we went by the first beach is called Beach C, D, E. There's a large area here with normally snack stands operating in the summer. We continue north here. When the road splits, and the split to the right takes us past Gunnison Beach, and where our ultimate goal is North Beach. The lighthouse is here. Here is the ferry and docking area and the Coast Guard base. This is where the tide gauge is. Okay. I mentioned that this was, again, formerly a Fort Hancock and Sandy Hook Proving Grounds. It's a National Historical Landmark, home to several batteries, Army batteries. Again, the oldest surviving lighthouse in the United States. And the quote, I believe this is the National Park Service that runs this, that's NPS. Since 1895, Fort Hancock was one of the places vital to American defense up to the nuclear age. Well, it goes beyond that because in the 1950s, this is the Nike missile base where we saw those two Nike missiles. If you went out here right near where we drilled, I had the pleasure of going out and having access to, it's not normally open to the public. There's a series of underground bunkers that are still there that preserve, not the missiles, they take the missiles out, but this is showing you a photo from 1950s or 60s showing a Nike missile base. So again, our field area is in North Beach. I have a little video here. So this is drone video looking to the south. And now this is where we just went in the car. We came across that bridge and went north. Now, if I was really, really good, I'd show you drone video of Sandy Hook Park. There's the video looking north into the park. But the National Park Service has banned all drones, including those for research. So even though we are currently doing research on Sandy Hook and we re-upped our research permit this year, they said, well, if we let you do it, then we've opened the door. So there's a complete ban on drone video, much to the shame. It would have been lovely. What you can see in a little snippet here that I was looking to the south, this is the Navesink River. We'll take you back there. This is the town of Seabright, looking to John's hometown of Monmouth Beach to the south. And again, it'll flip around, and there's the Route 36 bridge, the entrance to the park, and there's the toll plaza. So, come on. This is still more or less of that area, showing you Seabright, which there's a seawall in Seabright. I'll show you in a few minutes. Seabright, of course, was very heavily hit by hurricane, well, by the time it hit Superstorm Sandy, it was no longer a hurricane in October 30th, 2012, and much of this town was flooded. And again, we're looking north to Sandy Hook. This is New York City in the background. This is basically Staten Island, Long Island out there. And what we're going to do today, you're going to have exercises. We have opportunity to do at the end when we all get done yapping. We can work in groups of 3. Professor Browning has sent out and posted on the webpage what we would like for you. You're going to construct 2 plots of the beach profile from Sandy Hook, one with no vertical exaggeration and one with vertical exaggeration of 15 times, which means that the vertical is 15 times exaggerated relative to the horizontal. We do vertical exaggeration so we can see things. We did it 1-to-1. You were not going to see very much, but it's useful to also remember when you're looking at maps and cross sections that are vertically exaggerated, it's useful to come back and look at them in a 1-to-1. You can use Excel or a graphing program of your choice to do this, and we will supply you with the data. We also will give you a beach profile from Island Beach State Park. I normally run this field trip to Island Beach State Park. Gail has usually gone to Sandy Hook. Sandy Hook has become more difficult logistically. It is closer, but the National Park Service has been a little bit more sticky than our friends at the Island Beach State Park, which is, of course, the New Jersey Department of Parks and Recreation. And write a paragraph explaining the similarities and differences between these 2 sets of profiles. We're going to take you and dig a trench from Sandy Hook, and we want you to include observations of sediment grain size, mineralogy, sediment structures, and geometry. We will give you some of these data in this presentation. And we'll show you a trench from Island Beach, and you'll need to compare the 2. Okay? There's also grain size data, 2 from Island Beach State Park and 3 from Sandy Hook. We want to see some graphs of that. and we'll complete a littoral environment observation sheet. John will take us through collecting those data first, but before we go to John live in the field, I wanted to show you various generations of photographs that we've taken. So this was taken in 1997. We took our geology honors lab. So if you were a major, you got to go up here if you were in the honors lab. And we took a series of photographs of Sandy Hook. Again, Sandy Hook Bay, Raritan Bay, the Atlantic Ocean. See how it looks like a kind of a tomahawk-like with lighthouse over here. We'll see that in a moment. Lighthouse is built here. What's really cool about this that we were able to capture with this particular image, each of these is basically a beach ridge, okay? Preserving the high area, the berm, probably from the winter, and sediment would then prograde and build out. So there's building out through time 1, time 2, time 3. I mean, this is quite historical. I mean, these were probably, just as a wild ass guess, if this is 1764, but this probably about 1800 here, this is the 1900s when these beach ridges formed. Again, more pictures of the tip of Sandy Hook. These are from 2007 and 2008. It looks a little bit different. It is built out more up here. North Beach, where we're going, is right here. So we will get to explore this region, which is actually prograding and accreting the most rapidly. John can correct me on that, but I think this is at North Beach is the most rapid accretion and progradation. Accretion means you're building sediments onto the hook. Progradation means you're building it out. So again, this is showing now the bay side around the tip. So again, the lighthouse is in here. We see a series. These are former officer quarters behind this breakwater, which is preventing any of them disappearing into Sandy Hook Bay and then coming down to the south here into the cove here. I think it's called Spermaceti Cove. Looking to the further south, this is the road, the Nike missile base is, I believe, right here for reference. So if we look to the south, we see the Route 36 bridge, we see Sandy Hook Bay, we see the Atlantic Ocean, and up here, these are the Atlantic Highlands, which is about, I think my memory is it's 220 feet, okay, for the highest point on what's called Mount Mitchell, and there's a condo perched right on the top of Mount Mitchell. The beach quite wide here. This is after beach nourishment. Okay, normally this is an area where we have heavy erosion, in fact, transport to the north. So we'll talk about longshore drift and transport later in lectures, but this is an important component that we have this northward transport of sediments toward North Beach. So Jim Browning asked me when we were on the beach, he goes, and JN, who's surveying it, asked, well, where is this sediment coming from? Well, a lot of it's coming from right here. So I like to call it, we rob from Peter to pay Paul. And Peter is where this is naturally eroding. And in fact, it wants to form an inlet here. And so Sandy Hook will become an island. That's a natural progression. Again, this is in October 2008. To check when this was nourished in Seabright, but it's been nourished something like 6 times. This is, again, the beach to the south with the wide parking lot. You can see the beach here and the bay side here. Okay. It wants to break through, though, right about in this area here. So, again, looking to the north now toward New York City, this is North Beach, where we're going to be on the ground in just a minute. Again, North Beach, and there's another picture of the lighthouse, which we haven't really seen a good picture of until this one, taken from the air. Again, this is showing you the area, in this area here, where we're robbing from Peter, okay? And it would normally break through during the next major hurricane. We're very well, depends on the process. It's pretty stochastic, or depends on the law of averages whether it would break through. But that's what would happen on average. This is showing the area just to the south going into Seabright, but this area had been, this is from Norb Sudi, had been experiencing beach nourishment, pumping sand from offshore, onshore to nourish the beach. Behind this seawall, though, it's normally eroding very heavily and exposing the seawalls you go into, particularly here in Seabright. It's very difficult to maintain a beach in front of a seawall. So this is pictures we took in 2007 after beach nourishment in Seabright. So this is the Navesink River. This is a bridge coming across. So for reference, I think Springsteen's house, he sold it, was there, and John Bon Jovi's house is right there. They both were worth, when they sold, in the tens of millions, and now it's in 20s of millions. Again, there's Bon Jovi's house, marked it on here. This is the Atlantic Highlands. This is a lagoon behind the barrier spit. Okay, and that's what this is, a barrier spit, because it's attached to the mainland to the south, and the Navesink River, and then the Shrewsbury River is just off to the left. This is a view on the ground from Seabright. These are privately owned beach access points. So the houses that are here maintain these, and they are not public. You can't just climb onto the beach. You can access the beach by walking along from Sandy Hook, as long as you stay within the below mean high tide on the beach. You are completely legal. They cannot challenge you, but they might. But you have the law on your hands. An interesting political statement is that despite the fact that beach nourishment is paid for by a mixture of primarily federal tax dollars, New Jersey, which rises typically 60% of it, New Jersey tax dollars, which usually comprises about 30%, and 10% local taxes. You as a citizen paying state and federal taxes don't have access to the beaches in many of these areas. This is only true in New Jersey, by the way, and it is a unique and sore point maintained by obviously a very powerful and rich lobby within the state. I'm not getting political, those are facts. The wall at Seabright is actually a focal point for understanding. So this is, again, the Route 36 bridge I took you over. So this is not out of the realm of where we are. You can see that this area was heavily eroding. The beach disappeared. These seawalls exacerbate erosion. So this is the wall, and you can see there's no beach in front of it until we New Jersey has spent $1 billion, okay, on its beaches. Again, mixes, it's mostly federal, 600 million of that's federal, but it is still, to nourish these beaches, has spent $1 billion. And that was since 1948, and we can expect that amount in constant dollars to more than double, probably within the next decade. Okay. Just looking to the south a little bit for perspective. This is moving south toward Long Branch and then to Asbury Park to the south. I started out with Bruce Springsteen's Sandy, a song about Asbury Park. And again, these areas are marked by these large groins that have been built out. These are not jetties, these are groins. A jetty is associated with with an inlet. And the first inlet, of course, is the Manasquan Shrewsbury inlets. So that I know it's showing those. So now we're into the trip. I've given you a background. We turn from the Route 36 bridge and we enter Sandy Hooks and come to the north. We'll take you through this. This is, again, a picture of the entry on the ground. John, when we, about 20 minutes after 1, I just talked to John, and he had just passed through this whole area, and he's on the beach now. So, John, can you give us a report from the beach? Hello, John. Sorry, John. Go ahead, John. We can hear you.
So I'm just setting up some of the equipment here. Ken, so are you ready for me now?
I can start with this video. So this is about a minute or a couple minutes of video to get out to you, John. So we'll start right now. We just arrived and gotten out of the vans. This is being taken by Jim and Masha. Okay, welcome to Gateway National Park, Sandy Hook. We are at the North Beach site of Sandy Hook that you will locate on the maps using Google Maps. It is Friday, September 18th, 2020, and we're going to give you a virtual tour of the beach. Our objectives are twofold. One is we're going to collect data and measurements across the beach of distance and elevation change and use it to make a beach profile. We're going to go from the far up into the dunes as we can go and then to the beach itself. Our second major objective is to dig a trench and look at the cross-section of the trench and look at the nature of beach stratification. That's it. So, okay, welcome to Gateway National Park. So off we set. Professors. So one thing is, as you can tell, it's quite windy on this particular day. My arms are really that bulging. That's the wind blowing my shirt. I think if I had known how it would look on camera, I would have worn a more form-fitting shirt, but this field work is not a fashion show. By the way, foot gear, when you go into the field, boots like Jim is wearing, it's a really good idea. But I also know that when I come back from a beach trip or a coastal plain trip, I basically have to empty my sneakers out of pounds of sand. And after a while, many trips, I just come back and throw the sneakers away. Okay.
Throw your socks away.
What's that?
If it's a coastal plain trip, you throw your socks away.
Oh, you do throw your socks away.
You might get the smell out, but you never get the green stains out.
So I've never been to this beach before. I've been at Sandy Hook, various places, but I'd never been to North Beach. You know, it's quite an experience. First of all, I got this little boardwalk that we can walk on. No lifeguards. Alcohol is prohibited. Well, this is federal and New Jersey. So we're about to get down to business. You all know you're not supposed to walk across the dunes because the dunes are the protection of the beach. This is a look across some of the dunes. We're going to enter the dunes on a footpath and try to do the minimum intrusion into the environment as possible. We're going to get about 80% of the elevation difference across the dune. Jim wouldn't let me go to the last 10, 20% up into the highest part of the dune. So we're carrying stadia rods. You see those rods in Jim's hands? They're graded. And each of those black and whites is 10 centimeters thick. In his left hand is a tape measure. Jim, how long is that tape measure?
I believe that was a 30 tape.
It's 100 feet. So I'm going up into the dunes. Now, if you see to the right, over right about there is a higher place. But this is where we're going to take our first measurement. So let me just, before, we got two options right now. One is to show you the measurements. What I'd like actually to do is, there was a third exercise, which I was going to do at the end, but John's on the beach. When you all have this littoral environment observation sheet. So we will record the year, the date, and the month, the time, So it is 1400 hours, 1411 to be precise. We're going to try and get to the wave period, the breaker height, the wave angle, the type of wave, the wind speed, the wind direction. Now, John doesn't have an anemometer in his hands, okay? We cheated by looking it up, and the winds are from the southwest, 10 to 20 knots, which is nautical miles per hour. We'll try to get some of this other information for you. So let's go to John. John, are you there? Hello, John.
Hi, Ken. Can you hear me?
Yeah, I can.
Sorry,
And you gotta mute yourself.
What's that?
Mute yourself.
Getting an echo.
Hi, Ken. I'm not sure what. So I'm gonna mute my computer right now. And hopefully this echo disappears.
So this is John Schmeltz on the beach at North Beach.
Hi, Ken. Is this better?
Yes, I can hear you quite well.
Okay. I'm talking through I'm talking through my phone, but the video is through my computer right now. So I don't know if it's possible to show my computer on the screen while talking through my phone, or maybe I have to like. Can you see my video right now, or is that?
I can see you quite clearly.
Oh, okay. All right. So I'm on the beach right now, and I have with me a measuring tape, a level,
I'm not
a
seeing anyone.
rod, and some corks. Anya, sorry, can you see me?
No, we're still seeing the slides. So if on your computer you do share screen, that might work. Or on whatever you want to show us.
Anya, can you hear me now?
That's good. So mute one of you.
One of them is muted. It's actually coming through.
Turn down the volume on your computer, maybe?
The volume on my computer is off. I only have one microphone on. I'm not sure what that echo is.
Okay, it seems to be gone.
Yeah, it's the audio on my computer for whatever reason has a severe echo.
Okay, I can see you on one version of you.
Here. Is this audio better? Probably not. So when I talk on this right now, you can hear me, but you can't see me.
We can hear you and see you.
Right now,
We're getting
right
the audio
now,
on the computer, but we can see you from whatever you're, yeah. It's just two different instances of you, but it seems to be working.
okay. So this works fine.
Yeah.
Okay. All right. Perfect. So I don't know how well can you guys see the waves right now, or the surface of the ocean? Is it clear or not really?
It's clear. I can't.
It should be hard to make out waves because there literally are none. It is a very, very, very calm day. So we'll go down to the water surface and just show how the measurements are made, but there really are very, very little in the way of waves. I have a number of corks that I'll throw out into the water. I measured off 10 meters just in front of me. We'll time that. And I sent in the chat, I sent a link to NOAA Tides and Currents, the Sandy Hook Tide Station, which is maybe half a mile from here, which has the wind speed. I don't have anything to measure the wind speed here, but they're saying that the wind speed at the tide station is from the west right now. I'm feeling it from the south. But I'll get a measurement on that. Is there a measurement that you guys think I should start with?
And I can't hear you.
I kind of think you're on mute.
In the meantime, do you guys see how the waves look like they're hitting to the right of the screen before they hit left? Like they're coming in at an angle?
We need to get them out further, the camera out further. Yeah, John, measure wave height, wave period.
Okay. Okay, so I'm gonna go down to the water surface. I might go a little bit further from the camera, but I think you'll still be able to hear me. So what I have is a rod. I'm just gonna walk down to the water surface. Can you guys still see me?
We're losing the video. We lost the video. Now it's back.
Now it's back. Okay. All right. So what I'm gonna do right now is I'm gonna walk down to the water surface, and I'm gonna try to match the top of the wave crest with the level at a level of along the rod. You can do this by using just kind of a level which I have in my hand, or you can look out and kind of match the wave crest with the horizon. I don't know how well you guys can see, but there really are no waves here. I think if we get like 10 centimeters of a wave, I'd be surprised. So I'm going to go down and just do that right now.
I think the computer is like up on the berm, so maybe we're not seeing where the waves are actually hitting.
Yeah, if we can get the computer to move it down closer, that would be good.
It's too bad the signal's so bad.
Well, he is on the beach. We're so particular anymore.
So I'd be getting wet to measure the waves. There are no waves today, unfortunately. I guess you could characterize the waves also as calm. Well, the method you would use is you would see me. The method you would use, you would line up your level out towards the horizon and try to match up the wave crest with either the tip of your level or the horizon itself. So if you can see the horizon over the top of the wave crest, your eye level is too high. If you can not see the horizon, if the horizon is obscured by the crest of the wave, then your eye level is too low. And then it's a matter of measuring where your eye level is relative to the water surface. Next, I will measure wave direction. So I don't have a compass. I do have an RTK measure. So I'm just going to make a line in the sand right here. And I'll measure both those points. I'm going to face directly into where the waves are coming, and I'm just going to take a few steps out, and then I'll measure that point. And then we can calculate the angle. So really coming almost straight on, but to like a southerly angle, a slightly southerly angle, so slightly south of east. And I'll make these measurements.
So you guys have learned how longshore drift works, right? Like, do we have any predictions about which direction he throws those corks in? Are they going to move to the left or the right of our screen?
Um, so, do you mind if I answer, Anya? Or should I wait?
Well, did here? You guys must have a prediction.
Will they go left,
I
or I
don't
mean
think we've
north?
learned about that yet.
Oh, okay.
Is it north? So the left.
Yeah, they're gonna go to the left because things pushed in perpendicular to the direction, so they're gonna be a little bit to the left. The waves go back out, they go out along the slope, so directly out of the screen is what we're looking at. So a little kind of zigzag, then they get pushed in the next wave, a little bit to the left, go back out, left, north.
Okay. So do you want to do? We'll do long short drift right now. I think I'm still in the shot, correct?
Yeah, you're just at the edge.
Okay. So right here is where I just measured a starting point, and walking to the other side. Here, am I still on the screen here, Anya?
It's laggy, so I can't tell. Give it a second until it animates again. There we go. Yeah, that's the other end of the screen.
All right. So this is 10 meters. So I'm gonna walk straight down to the water. I'm gonna throw the corks in, set a timer, and then I'll walk over to the other end and see when they cross that 10-meter point. Anya, actually, would you mind? Do you have a stopwatch on you that you could time this with?
Yeah, just use your voice because I can't like the video isn't it's and
Okay. All right. So
okay, ready.
all right, I'll give a shout when I'm ready to start. You'll see me. Hopefully, you'll see me throw as well.
That's unlikely.
No, Anya.
Start.
Yeah, sorry, Anya. Did you hear start?
Yeah, I got it. Just out.
All right. So can you guys? I'm guessing you guys cannot see the corks.
No.
John, is it possible to move the laptop closer?
Yes. I'll come. I'll go get it right now.
Yeah. I mean, I don't want you walking into the ocean with a laptop. I don't want to have to buy another one, but so folks, when you go in the field nowadays, people go in the field with iPads. Thank God iPads are down under $300 because there's a lot of iPads that go flying and whoops. Yeah, there we go. Now you can see the beach.
As you can see, it was impossible to measure the waves.
Not a good surfing day.
So I can't see the corks. They are in the screen. They are moving north. They're getting close to the 10-meter mark. Here, I'll.
So Quentin said he can confirm he had a coworker almost drive over their iPad on the site the other week. Yes. I have a tendency to bring my very expensive MacBook Pro into the field, which is why I usually have two MacBook Pros in case something goes wrong.
The first cork is just passing the 10-meter mark right now.
Okay, 2 minutes and 22 seconds.
And I'll let you know
All got that?
The second cork is passing now. I don't know if you want to record all of them.
Write them on my hand. I'm gonna run out of hand soon.
The third cork just passed.
Was that another one?
Yeah, they're waiting on the last cork right now, and it's just passing right now. And that's a fisherman walking by.
Were there 5 total?
There are 5, but I've lost one.
Well,
All right, so actually, this was poor data collection on my part, but the 5th cork is way ahead of the others.
Okay.
So what I can do is I can actually I'll walk off where that cork is right now, and if you can just write down a time, I'll measure it
Okay.
after we're done. All right. So just measure that cork, that 5th cork time, and we'll just have to make a new distance.
Right now, or when you started talking about doing that?
So like now minus 5 seconds. I don't know if you guys can see this, but a
Okay.
couple of fish were just cast into the ocean, and there's a giant swarm of fish jumping. So I guess
Oh
this
yeah.
might be.
Cool.
Yeah. So Anya, can you do the timing again? I just got way too close to a fish hook. Can you do the timing again for the wait period?
Yes. I'm
So
resetting. So tell me when.
why don't you tell me when to start, and I'll count out. I'm gonna count out waves just breaking right here at the shore.
Okay. Ready, set, go.
Okay. I have 1, 2, 3,
How long-
4, like 20 seconds.
Oh, okay.
5, 6,
Stop.
7. Okay.
That was
So
6 seconds.
7 and 20 seconds.
Okay.
So you can make your calculations from there. So next we were gonna wind speed and wind direction. Right now it feels like it's coming from my back end. I did send you guys the link to look at NOAA tides and currents and their measurement. I have it coming from southwest, and I just did the same thing that I had done with the waves. Was there another measurement we needed to make?
well, there are no rip currents, obviously. They'll
No,
get low tide. What's the air temperature there, John?
I believe it's about 70 degrees.
Oh, wow.
That NOAA link has the air temperature. I'll
Okay,
check.
Noah. Yeah. And what's the angle when I know it's not much of a break, but what's the wave angle?
The wave angle is, so I don't have a compass on me, but just from in the direction of the shore, it's about, I would say, 5 degrees.
Say again?
But my best approximation is that it's maybe 5 degrees, but I can get
Okay.
that exactly.
No, that's fine.
Yeah.
General numbers, okay. Breaker height is 10 centimeters, which is a third of a foot. Since they want it in tenths of a feet, that would be about 0.3. And the wave period, is there any period to the waves, John?
Yes, well, 7 and 20 seconds. So
Okay.
each wave has a period of a little over almost 3 seconds.
Okay. So now we have this information that you guys can record on the littoral environment observation sheet. John, I'm going to turn it over to Jim Browning at this point, and resume the PowerPoint. Thank you, John.
No problem.
Yeah. It was, well, without glitches, but it was good. Thank you. Okay. So let me get to share the PowerPoint again. So Jim, you're backlit right now. There you go. That's better. Can you guys hear me?
I can hear you, yeah.
Okay. I just want to make sure. I tend to get muted when I switch on and off PowerPoint. So again, this is the littoral chart that you should fill out with the information that we just gave you, John just gave you. And as an example, for the day we were in the field, the 18th of September, these were the conditions. Okay, you should look at that and compare it. And so now Jim is going to tell you how to do a beach profile. I'm going to mute myself.
Okay.
Go ahead, Jim.
Yeah, hi. So what we're trying to do here is get some idea of what the profile of the beach looks like. And the reason geologists and scientists want to do that is so we can compare this from place to place and time to time and see how the beach varies. That can help people understand why it varies, what are some of the variables that go into why the beach is changing. But you have to have the data in order to know why things are changing. So in a perfect world, you'd be out there doing this and I wouldn't be lugging stadia rods around. But we don't live in a perfect world right now. So what we're doing is trying to get an idea of distance and elevation change. So Dr. Miller and I started somewhere behind the dune or on the dune. And we made a profile measuring horizontal distance on the ground, and then using the stadia rods and our hand levels, we could get an idea of what the change in elevation was. So what we would do is we generally used technique 2. We did not use technique 1. So we're just going to explain this one. We had 2 stadia rods, and what we would do is use the level to line up a spot on my stadia rod and see where it intersected the other stadia rod. And that would tell us how much of a vertical drop we had or a vertical rise. We always had to be very careful to notice whether we were going up or down. Fortunately, we had Dr. Masha Makarova helping us, and she's very stickler for details. So she was able to make sure that she knew whether we were going up or down at all times. So in the canvas, I've got a module there called Field Trip Sandy Hook. There are several different files. The field trip guide is there as a PDF and as a Word document. And then there's also 2 files, one saying Sandy Hook profile, and another says VFT, which is not VET, it's a virtual field trip island beach profile. And so what we did was we measured this. Now, I think there's some other pictures. Ken, could you advance one? This they can read later. Go ahead and go again. This is a picture of us measuring. Whoever was the lower one would have the hand level. We each had a hand level. Masha liked pictures of the beach. So yeah, we were about 400 meters from the shoreline. Could you advance again? We can't, you're muted, Ken. I don't know if you're talking. And there's a picture of us. Well, that one's gone, but this is a picture of us trying to get the tape straight and make sure it was level so we knew how much distance there was between our two stadia rods. Now, John showed us that we're not using the most up-to-date and modern techniques. Modern surveyors would use electronic equipment, and they would get a very high degree of accuracy, quite a bit quicker than we did. But there's nothing like getting your hands on the ground and really trying to figure this out first before you have the computer do it yourself. Anytime you're working with a black box and you're just getting a machine to do things, you don't really know what's going on. So go ahead and show that one, Ken. Not sure what we're doing there. She got a lot of pictures of us falling down, I think. Trying to figure out where the level is. So we know how far down is my stadia rod. And I'm asking him to put his finger on a particular spot on his stadia rod, and then he'll be able to judge how far down. Each one of those, I believe, was 2 centimeters wide. So major tick to major, black to black was 10 centimeters. Can you advance one, Ken? Yeah, when we went downhill, now we're supposed to be able to shoot to the horizon. We didn't do that. We just continued to use the equipment.
I'm recording this.
Apparently, I used a bad word there, and Masha thought that was quite funny.
Jim, it should be noted, though, that we were so far away. This beach is so wide. The exact numbers are in the data, but we pasted off. We did this part for the dunes where we were going downhill, and then it hit an incredibly 300-meter long flat.
Yep.
Where there's no up and no down, hardly at all. If you used a very high high resolution electronic total station, ETS, which we have at Rutgers, and John had even a fancier one because he loves toys. We perhaps could have measured the very minor differences in grade, but it was basically as flat as a ping pong table until we got to the beach. So what we did is we did the measurements where there was a significant grade shooting back up slope. We then walked down to the beach and then shot down by the beach.
Yeah, we walked about 300 meters, about 1,000 feet across the beach. What you'll notice in that data table is that measurements are in two different types of measurements. We've got meters for the distances because they were so long. The elevation changes are in centimeters. So you're supposed to do plots, 2 plots profile Sandy Hook. One with no vertical exaggeration, just to see how flat it is. But be aware that you don't want to compare centimeters to meters. You got to use the same units. The other one, we want you to try and blow things up and see if you can figure out how to do this. Get a 15 vertical to 1 horizontal. This will allow you to see the changes that we have in the profile. And yeah, there's going to be a 300-meter where, yeah, we didn't actually shoot it. We just said, looks flat to me. Does it look flat to you? Yep. We walked across the beach. So now here we are at the other side of the beach.
Last measurement before we go down again.
Last measurement before we go down again.
Our measurements were within a centimeter of John's every time. I think we had
last measurement before we go down again. All the way to the waterfront.
Okay. We had about a 10-mile-an-hour wind that day. Then we were going on our tape measure. So we just played it supposed to get nice tight measurement. The wind plays that day. And you get 164. Beautiful day. So
Yeah. Can you hear me?
yeah, I can now.
Yeah, I'm just going to keep putting it on a loop for a minute, but so you can see us doing the measurements, but John's doing it with one hand and much faster because he's using an electronic tool.
Yeah. But
Where does he get those wonderful toys?
John has done it the way we're doing it. John is aware of this mechanism. He knows how to do it. So he understands what's going on. He's not just throwing things into a black box, if you will.
So apparently we didn't know this when we went out there, but John told us that right where we were, within 50 feet to the one side, is where Norb Suddi's been taking these measurements literally since the 80s, like early 80s, not the 70s. And he'd go out there many times during a season. And so there's a whole series of beach profiles that John has compiled. I'll show you those in a few minutes.
Okay, about as far down as we got. One more. Sugar,
Back up, Jim. Back up. Yeah.
Okay. There's also in that file something that says VFW Island Beach State Park, which is a profile that we did at Island Beach State Park either last year or 2 years ago. I don't remember. I'd have to look back at the file that Anya sent us. This is another beach. This is further to the south at Island Beach. And I'd like you to make a profile of that, make that one 15:1, and then compare the two profiles. Look at the two profiles and see how they compare to each other. Make some comments, about a paragraph, nothing big, but explaining the similarities and differences between the two profiles. Okay?
So I just want to say a couple words. We'll be spending a lot of time here when we start talking about shallow water facies model. This is also a peninsular spit, which is called Island Beach State Park. You'll find Snooky and Sleeside up here, just not too far to the north. But this, if you come through the town of South Seaside Park, you enter Island Beach, and I'll take you through that. But the difference is there's an inlet here, which is called Barnegat Inlet. And where I like to take the students is a place right here. It's the Emily DeCamp Interpretive Center. It's a former Coast Guard base, which we drilled our first deep core hole in 1992 at Island Beach at this former Coast Guard base. And what's nice about this is that there's a interpretive trail, interpretive because it shows you all the vegetation. This is worth going to. It's worth going to now. If you have nothing to do tomorrow, get in your car and drive down here, folks. It's free. There's no beach chip fee charge. You go down there. Tomorrow is going to be a Mr. G best 10 day for weather. Take my word for it. It should be really good. But if you go through, and I'm going to take you through the dunes of this in the next couple pictures, and we'll go here where we did our beach measurements. We also marched a class over into the marsh side, which is a little less pleasant depending upon the weather. Tomorrow will be lovely to do this walk, but often when we've done it in early September when it's quite hot and the bugs are still around, you can get eaten alive on the beach side, particularly by greenheads. And some of the classes still are mad at me for getting so beat up by. This is called Island Beach State Park. And if you go south, there's a 9-mile road. It ends into a four-wheel drive road in the last mile. But it's just coming around the last corner here. There's the Emily DeCamp Interpretive Center. You can't miss it. It's on the left.
Well,
it's the only building. And you'll see the building in a minute. It's a red Coast Guard station.
They've got a big sign there. It's well marked, Ken.
I mean, that's it. You can't miss that building. Okay. So this is looking from the beach back across the dunes toward the where we drilled, and which is now the interpretive center. This is the beach side, just showing you some of the marshes out here, and we'll talk about marshes later. I don't want to bore you with it now. So this is the beach at Island Beach. This was a class from a burn seminar that I ran. Our TA, Ashley Harris. This is my son, Rob, from 10 years ago. Now works for an environmental firm. He was a geology major. One other student here, Helen, received her PhD from Lamont, and she is now a professor at University of Hawaii. So we've done pretty well with this group. What you didn't see so far, I wanted to show, this is a very nicely preserved berm at Island Beach. This is basically the shore face here. So when we hear about those terms, basically John had you on the shore face. The berm was actually pretty far behind him. This is from 2008. And of course, this is the dune. So this is a picture. There is a trail that comes across, but this is the natural dune that, of course, you don't want to walk on, because these beach grasses stabilize the dune and help protect it from erosion. The dune separates, is a landward margin, many beaches, and it separates water processes from aeolian windblown processes. So think of the same processes that make dunes in the Sahara and making high angle crossbedding. So I will actually show you a crossing through that dune during lecture, but now we're going to move ahead and go to the trench. This is like a North Beach now.
Sorry.
Everybody takes a turn with the shovel. You can see it's pretty snotty out there, as we would call it nautically, in terms of the wind and the spray and everything else. It wasn't the most pleasant day here on 18th of September. We got a nice trench here, and you can see those black laminae, all right, which really are quite spectacular. So, Jim, you want to describe it?
What we're doing here is we're trying to go from the modern and go back just a little bit into the past. Dr. Miller will take you further into the past because he's going to tell you what happens when you do more than just dig a trench. But now we're trying to see some processes that have taken place in the past. So what we want to know is, what does a beach look like? What are the modern facies that you would expect to find at a beach? And we do that by making our own outcrop. We dug a trench, and you saw me and John, and the other guy was JN there. He works for the core repository. He's also a graduate student here. He's a master's student. I think you'll see some of his data hopefully pretty soon. So what we did was we dug this trench, and this is one of the pictures, and you can see that there are lines, laminae. A lot of these are less than 1 centimeter, so these are laminae. This is the stadia rod, so each one of these units is 2 centimeters, and from black to black is 10 centimeters. And what we want you to do is, we'll have to, this picture's not posted anywhere, Ken, in particular for them to look at. We'll have to get them something that they can actually draw. Could you go to the next picture, Ken?
Oh, ooh, ah.
Yeah, and you can see that this is what a modern beach looks like. If you see something like this in the rock record with all this sand and some laminae, well, that's roughly what we're looking at. We're looking at beach processes. This was a gorgeous trench. This probably represented several months worth of accumulation. There's storms in the winter that cause erosion, and then deposition takes place throughout the summer. So this probably took place, I think John said it was probably a spring storm deposited these things up on top of the beach. Can you show another picture? Do you have anything to add, Ken? This is
we need to talk about the composition of those black laminae. It's not
We've got
organic
sand,
matter.
we have sand pictures.
Okay. That gives you a nice three-dimensional view looking beachward. I mean, sorry, looking landward.
As Dr. Miller pointed out in the field, ideally, we would have had, enough students, we would have had 4 trenches, all within a few meters of each other, maybe 3 or 4 meters apart at most. And so we could try to see if we could trace these laminae from one trench to another. We did a little digging out. I don't remember which side, but Dr. Miller showed that they don't go very far. Some of these laminae are very limited distribution. You only see them a little bit. I suggested digging another trench, and they threatened to bury me in it. So we only got the one trench bit dug. You got another picture for me, Ken?
Yeah.
Jim, are those burrows?
No, what? No, I don't think there are any burrows. Well, that's us burrowing.
That's a little washdown, not a burrow.
Yeah, that's probably somebody's shovel got caught in there. Good
Yeah,
point.
these are-
But no, I don't think those were burrows. I didn't see any interruptions in these laminations while we were out there. They were laterally continuous and now, okay, they were lateral. So what we want you to do is draw a picture, probably that one right there. Draw it to scale. And you've got the stadia rod there for scale. So like I said, each one of those different colored patterns is 2 centimeters. So from black to black or yellow to yellow is 10 centimeters. And you can use that to help make a scale drawing of that trench. And you can get an idea of what this looks like. Keep an eye out. There's a lot of small, thin burrows in there as well. I mean, thin laminae in there as well. It's not just big things.
So, guys, I'm showing you something I just saw myself for the first time literally a minute ago. J.N. Stanley went out and was out there with John and did a ground penetrating radar study. They're really useful for finding things like buried graves and buried gas tanks and all that. But they are also, J.N.'s giving this talk at the Geological Society of America in 2 weeks. And so this is the same trench, and he ran the GPR off of it. And that these various surfaces make nice reflections. So there's the strong reflection that he sees right here on ground penetrating radar. Down here, how many was it? Basically about a meter is shown up on the ground penetrating radar, which I thought was pretty cool. And then the next slide, they're showing you these are, we talked about the shore face, right? So we're able to image the shore face, ancient shore faces. But as John says, this is probably from, maybe a major storm from a few years ago, or maybe more recently even, on this ground penetrating radar. And I'll take you through this again, but this is pretty damn cool that they're able to do this. So that was JN's talk. So let me just get back to the other computer, which is where we were storing.
Ken, show them the picture of JN operating the GPR.
Oh yeah, okay. So again, well, I'll show 2 things. One, these are various profiles that were obtained, including this more recent one showing that this is beach now, wasn't beach before. This was the ocean, okay, back here in these older times. And so this is where we are from where the survey is. The trench, I believe, was dug right there. And this is, they used this wheel card on the beach. Okay, this is good work if you can get it, with a 400 megahertz antenna ground penetrating radar. And there they are, starting at the beach, JN pushing the card across to show the trench, and then reflect the profiles that I showed you. So we're back at the original PowerPoint. Now we're going to go magically transport ourselves from Sandy Hook to Island Beach. This is last year's trench that we dug, 3 trenches with the undergrads on the field trip. Jim, what do you want to say?
Yeah, this is another trench. This is similar in depth. Now, there's no stadia rod in there, unfortunately. Well, there's a stadia rod on top. So we do have a scale that's available there. It's not as well placed. You do have somebody's hand and somebody's shovel right there, trowel. But you'll notice there are differences here. We're still seeing laminations. We're not seeing quite as much structure. We're not seeing the same grain colorations. There are differences between this beach profile and the one from to the north at Sandy Hook. So for the assignment, I'd like you to make another drawing, scale drawing of this. And yeah, it looks like Dr. Miller is tracing out what looks to be a horizon there on top. And there looks like there could be some sort of an angle between the stuff down below and the stuff on top.
So for reference, to the left is landward toward the dune, and to the right is where you're going to get your feet wet. Okay? Not the bay, the ocean.
Right.
To the right is the ocean, to the left is the dune. You're on the shore face.
So again, like you did the last time, make a drawing of this, make a drawing of the trench to the north at Sandy Hook, and write a paragraph in which you discuss and compare what they look like. Now, what we did was we took some samples from the beach. I'm only going to show you two here. We took a few more, but this is from sand that was on top of the trench. If you look very closely, this is just something I took with my phone down the microscope tube. There is a graticule in that looking down the microscope tube. And that is about 14 centimeters across, I believe that was.
Yeah, each of these is a centimeter, right?
Right, I believe that was right.
14, 13, 12, 11, 10, 9, 8.
No, that can't be right. That's 1.4 centimeters. That can't be centimeters.
Yeah, those are in millimeter.
Those are in millimeters. Yeah, what am I talking about?
Thank you. Sorry.
So you can look at that and you can do a description of the sand. Most of the sand that was found at Sandy Hook. This is, it doesn't say on the slide, but this is Sandy Hook on top of the trench. You can identify those minerals. You can tell me what the grain size is. You can tell me something about the roundness and the sphericity. You can also tell me maybe you could tell us whether there are other minerals in it. What is the mineralogy? There certainly are some dark grains in there that, I think I know what they are. But you can get some idea of what a beach in New Jersey looks like. Now, we also took a sample from one of those laminae. I think it was the dark laminae. This is what the dark laminae looked like. Now, I think we got mixed in with some of the other sand here. But this is a very different one. You've got the same graticule in there. It's showing you 14 millimeters across. But you can also get grain size here, and you can get a lot of minerals in here. I guess I'll give it away. Should we give it away?
Yeah, I was surprised. Well, go ahead, Jim.
Well, go ahead. I mean, there are most of the white and shiny grains are quartz. In fact, that seems to be what most of those white and clear kind of shiny grains are, but there's a lot of dark grains.
Make them guess.
Go ahead, Anya, what?
Make them guess. They know things.
They know what the green mineral is?
What's the green mineral, guys? Dark green?
Is it glauconite?
Glauconite.
Yeah.
Yes, it is.
Some of the black grains are what we would call opaque heavy minerals, generally zircon. There are a few zircons in here, rutile, which is more common, I think, according to the Pete Sugarman on this beach, and tourmaline. Those are heavy minerals. They are heavier than quartz in terms of density. The glauconite is a lighter mineral. It actually, if you use the right heavy fluid, will actually float. It is less dense than quartz. So one way to separate these out would be to use heavy fluids to float them.
I think there's also a number of red grains in there. Some of those are iron stained quartz, but I think if you look, yes, I think if you look carefully, that one, they made
That's iron
garnets.
quartz.
They
There are
made-
garnets.
What's that?
There are garnets, but where? That one, I think.
Yeah, there are garnets in there, the brownish red, brownish, I think, red ones.
So where did the garnet come from? Ask the class.
Yeah, because you don't ask me, I have no idea.
All right.
Pete McLaughlin brought them up.
Was it the weathering of like basaltic oceanic crust?
No, it's probably from weathering of material in the highlands that came down the Raritan River. Okay, because you're not seeing a lot of garnets from the Newark Basin. All right.
The garnets are metamorphic in origin, aren't they, Ken?
Yeah.
So it's got to be some sort of a metamorphic terrain somewhere. Maybe the New Jersey, the Highlands province of New Jersey, something like that.
So that would have been my guess, and I'd have to call Scott Stanford from the New Jersey Geological Survey, because it's also possible that these things are brought down by glaciers, some of the metamorphic materials, and reworked. And so the glaciers came down to, well, they didn't hit here, and we'll see in a minute, and I'll end showing you where the glaciers were. But they did get to Staten Island as a terminal moraine, as does Scotch Plains and Edison. So, I mean, the terminal moraine was pretty close. So it could be from that too.
Okay, there's one other bit of data that I put into onto the Canvas site, and it's grain size data from Sandy Hook and Island Beach State Park. I took some of these samples and I sieved them. I put them in the row tap that we have sitting over here, sieved them and weighed the different fractions out. Those two that you saw from Sandy Hook, plus another one at very low tide. We were kind of very surprised. The beach was very coarse, mostly very coarse sand to granules. So I had to get a couple of extra sieves in order to do this because it was not just sand. There was a lot of gravel in there. In addition, we have some grain size data from Island Beach. So I'll give you extra credit if you graph up the grain size data and use that as part of your explanation of how Island Beach
I'm just playing this in the background, Jim. It's just you getting ready to do the same exercise that John did with corks.
Yeah, you're going to see my baseball arm here. I can make it all the way from home plate to all the way from the pitching mound halfway to home plate. I can almost make it off.
There you go.
The idea
We'll take it for a ride, not to show this.
Oh, there we go.
That was good. The wind.
We ideally wanted to get it out beyond the breakers.
No, the wind got that second one. Sure. The first one.
Even Chris Johnson can get that one.
So that was, again, the exercise that we took you through at the beginning. And here's the instructions that Professor Jim suggested that what we need to do. So I'm going to take over. You have anything to add, Jim?
I'm good, thank you.
I just want to give you now about 10 minutes of context. I don't want to drool on. But Sandy Hook, we went back several thousand years ago, wasn't there. I mean, if anything, it was far offshore. And we'll talk about my favorite topic in detail, but we're talking about the late Quaternary history of Sandy Hook. And these are calendar ages before 1850, which means 1950 rather, which is radiocarbon ages. We refer to 1950. And so the last glaciation reached a peak somewhere between 27,000 years ago and about 20,000 years ago. And then sea level was 120 meters or so below present and rose. And during the Holocene, it slowed down, and over the last 6,000 years, slowed to almost nothing over the past 4,000. And so to investigate this history, we drilled 3 core holes, one at the South Maintenance Yard right next to those Nike missiles, one at the salt shed, which is just a place they stored things, and one in the North Maintenance Yard. So maintenance yards are good places to work because you have security and you have other people there. So when you're parking a drill rig overnight, it's likely to get vandalized. If Pete McLaughlin's still on the line, he'll tell you about in certain places where they had in Newcastle where the drill rigs got vandalized overnight. So John Schmelz put together this map in his presentation with JN for GSA, and just shows you that the hook is building out, and to a certain extent over here, building this way and that way. And again, the material is being derived from the south, a lot of it from local erosion, some of it from probably beach nourishment. The material doesn't last, it goes somewhere. Well, where does it go? It goes out here and builds outward. So again, this is North Beach right here. So this is where Sudi has taken Norb Sudi has taken a lot of historical data on beach profiles. And so that's where John's able to compile this and into this beautiful map through time. And you can really do fun things with maps like this. And so the beach is shown here today, and then showing you the dune, the forward dune, okay, sand flats and all that kind of stuff. So you can add all that kind of information. Again, the history is, well, I would say this is somewhat speculative. This wasn't exactly from a famous publication. We took this off the wall of the Spermaceti Cove Visitor Center. But it basically shows, here's the Navesink River, the Shrewsbury River, Sandy Hook Bay. It's showing you that for much of the time, Sandy Hook was actually an island with an inlet here, or an inlet there, or an inlet here, okay? And these are historical. So when Henry Hudson was the first one to sail up this coast, there was probably an inlet that I don't think he actually sailed into it, but he could have. And of course, that has become what we know is the present day Sandy Hook is essentially more of a 20th century to 21st century feature. Even as recently as 1896 to 1900, there was an inlet here. And so that is reasonably well known. Our objective was to study the Quaternary and older history. So I'm more interested in the Cretaceous strata here, which in the coastal plain here are dipping basically to the southeast. But this is a big, thick pile of sediments that is prograded out. This profile here, this cross section was drawn by the late Jim Menard of the United States Geological Survey, the USGS, in 1969. This is the section A prime. That's how they usually do things, section A to A prime, A to A prime. And it's to scale. So the North Maintenance Yard's here, salt shed's there, and South Maintenance Yard. We were guided by auger samples that Jim took. These are basically, if you think about it, if you ever used a post hole digger and you bring up stuff from the bottom of a hole, you get a kind of mushed up sample, and they got mushed up samples. We continuously cored this to get a record of the Quaternary and then into the Cretaceous. We drilled this hole at South Maintenance Yard, went down ultimately to about 800 feet. From this, Scott Stanford of the New Jersey Geological Survey, working with us and our team at Rutgers, put together this cross section through time. And we had different gravels that they interpreted. Basically, he interpreted these as being material that flooded in after the glaciation, but based upon the level and the mapping of this to Tills and Staten Island, he interpreted these gravels at the bottom of these two holes, the bottom of the Quaternary, as glacial gravels. Okay. These are gamma logs, low values in sand, higher values in muds. And so these are muds. here, and we'll show you that in the next figure. Brown is drawn as mud, so you can see this is mud dominated. And then there's sands here that basically coarsen up, and then the modern basically beach developing here at as sea level rose. So Scott put these together as maps, kind of showing you how the hook, predecessors to the hook, and then how the modern hook evolved through time. The top left is showing you Raritan Bay, Staten Island here, Sandy Hook. It's showing you prior to about 26,000 years ago, the drainage from the Raritan and the Hudson rivers here, small rivers here to the south. During the late glacial maximum, the terminal moraine, this was all ice, okay? It was 1,000 feet thick in Manhattan. It would have covered the Empire State Building, but not the World Trade Center tower. And in terminal moraine is where it all ended. And this all out here is what we would call an outwash plain. So if you want to see boring areas of the planet, go to an outwash plain. I will show you, or Professor Jim will show you an outwash plain with braided streams, very topical what we're covering from Iceland. Or if you've ever driven to Montreal, the last 2 hours of the drive, you get out of the Adirondacks, is an outwash plain. It's incredibly flat and boring. At about 18,000 years, the glacier is receding. It opens up flow. There was a breakthrough in the Narrows here to open up the Hudson again. The Hudson, which had previously come through northern Manhattan and probably not far from the modern Harlem River, and cut through JFK Airport, assumed more of its modern course at about 18,000. Okay, our modern mighty Navesink River, which is something like 16 miles long, not even that, comes here as a feeder into the Hudson. And then during deglaciation, as sea level rapidly rose, these rivers became flooded, and it became what we call estuaries. And so this is the position basically of the beach 10,000 years ago and about 5,000 years ago. And over the past 5,000 years, the sea level globally has not done almost anything for the past 5,000 years. This area is still and is subsiding, so it took a little while for it to get to equilibrium and form the modern spit barrier system. So I think the last thing I said, I was interested in the Quaternary part from a sea level perspective, and what is we dated material from radiocarbon here at Sandy Hook in red. These are other estimates and measurements of age and depth from the whole New Jersey region, showing you the relative rise in sea level over the past 10,000 years before present. Again, something weird, present's defined as 1950, okay? Just since the present always changes. So it's defined as 1950. And we'll talk about this in class when we talk about sea level, because it's not simple. As I pointed out, we are here in New York, and this area has, over the past 5,000 years, has still seen some sea level rise, even though global sea level more or less stopped rising. The reason why is that this is what I call the seesaw effect. The melting of these large glaciers here. You can think of this as the nutritionally challenged kid on the other side of the seesaw. He's sitting there weighing you down, and you're way up in the air. After he gets off, you begin to sink. So this area here is sinking at about 1 millimeter per year. So that's all I have for the little bit 10-minute blurb at the end to give you a little context about Sandy Hook and why it's a very interesting place.
So the rest of the time you can spend working on your assignment. You're muted, Ken. You're muted, Ken.
Jim, did you put up the photographs?
No, I have not. Yeah, I can pull them out and I'll just put them up on the,
Canvas site.
on the Canvas site. Sure, I'll do that now.
Okay. So guys, we know this isn't the same as going out there. We tried to give you a mixture of all kinds of media to help. Drone footage. We couldn't have good drone footage. People on site today. We tried to put together with some video to really appreciate this and some real data to see the context. But there's nothing to be, no substitute for going into the field. So hopefully next summer, field camps will be running throughout the United States. We hope so anyway. Although who knows? We still don't know right now. There may be a tendency to have what happened last summer, which is all virtual field camps. We need to get out into the field. And we hope you do. But who knows how it will evolve. I just got an email today that Broadway is officially closed for May 31st. They made the decision to extend it. So it may be that field camps will not go next summer. And if it does, it will be unless there's great success, even if the vaccine's in place, there will be a social distancing and precautions. So if we are thinking of running our field trip in May, we will do it in a manner where 4 people to a vehicle and 4 people then to a room, and they're the same 4 people, so we can keep people in pods. It's a challenge. Anya, is Anya here? Do you have anything to add? Or Jim?
I took notes on all the numbers that John gave us, so if anybody needs anything, let me know.
Yeah, put them. A couple people asking in chat, and I sent some of it around.
Okay. I'll pop into the different rooms once you guys are in breakout rooms, so you can ask me there too.
Can you
Are we not
put
doing
up breakout rooms, Ken?
We could.
If they're supposed to work in groups of 3?
Yeah.
They can if they want to.
Well, we'll enable breakout sessions. Enable breakout session assignments. Assign 19 participants into 6 sessions, right? 5. I think we have Pete, Jim. I'm here twice. Well, first of all, let me quit.
Okay, let's go where.
Okay. Still showing 19. I don't know. Okay. So we have a breakout session. Greg Mountain will not stay with Quentin and Ronan. He'll drop off. Emir, Anya, Journey, and Serena. Emily, Jared, Jesse, and Kirsty, Derek, Jim, John.
Is it?
No, that doesn't work.
Can
Yeah.
so I can jump between rooms?
Yeah, I don't know. Can Derek jump into another room?
I think you have to do it.
I don't know what I could do. I think you may have to move me.
Yeah, I know. Yeah, I moved you to 5. I want to remove Greg. Yeah, okay. Breakout 4 is going to disappear. Breakout 5 is Christian, Derek, Esther, Michael. That's good. You can work in a group of 4. Breakout 4 goes away. Breakout 3, Emily, Jared, Jesse, and Kirsty. That's cool. Breakout 2, Amir, Journey, and Serena. And breakout 1, Quentin, Ronan, and Sri. Okay, we're going to start breakout groups. So I'm going to sign off. Well, I'm not going to sign off because I'll kick you all off, but I'm going to mute and stop my video because I had to join another meeting when I'll use my other computer. But I'll keep this one active. And so you can start breakouts.
Ken, do we have a list somewhere of everything that we're needing to turn in?
Yeah, Jim?
Yes. Anya, I went through that as we went along, and it was in the field trip guidebook. There's a what to hand in.
Okay, perfect.
Okay.
Okay, bye guys.
All right, what's going on? It's breakout session. Okay. Pete, are you still around? I'm going to stop recording.